In this video, we're going to find dy dx using implicit differentiation, and these are the 4 problems that we're going to do in this video. And I've got the answers there because you need the answers to be able to check. So this is what the entire video is going to be about, so you can decide now whether or not you want to watch the video. All right, rightio, let's just get started. So I'm going to make some room to work. So if I'm going to find dy dx, then the first thing I'm going to do is I'm going to differentiate everything with respect to x, everything. So I can do that to each individual term. And I can take that 6 out. Okay, so the derivative of x cubed with respect to x is just 3x squared. The derivative of y cubed is 3y squared, but we're taking it with respect to x. So then I have to multiply the derivative of y with respect to x, or dy dx. Now here, that's a product, and I'm going to have to use the product rule, which says it will be the derivative of the first one, and the derivative of x is just 1, times the second one, plus the first one, which is x, times the derivative of the second one, and the derivative of y with respect to x is just dy dx. Okay. And now I'm going to multiply that 6 back through. So 6 times 1y is 6y, and then I'll have that. Now, I want to solve for dy dx, so everything we're doing after this is just algebra. You want to get dy dx by itself on the left-hand side. That's the goal. So right now, this has a dy dx in it, that term. I need to get it over to the other side. So I'm going to do that to both sides. So that has the effect of getting rid of that term, canceling that term. Now this term here does not have a dy dx in it, so I need to get it to the other side, and so I'm going to subtract that from both sides. So the effect that has over here is that's canceled. Okay, so now let's write it out all in one color, nice and neat. I will have 3y squared dy dx minus 6x dy dx, then equals, and over here I'm going to have 6y minus 3x squared. Okay, I'm getting very close. I want to find dy dx. Every term here has a dy dx in it on this side. That's by design. I am going to factor it out. And I'm going to continue this over here. I'm going to factor out dy dx. So again, this is algebra. And calculus students absolutely hate factoring. So when I factor out dy dx, I'm going to have left 3y squared minus 6x. Now, I meant to find dy dx. I have dy dx times something. So, divide both sides by whatever it's multiplied by to get rid of it. So, by design, these will cancel, and I will be left with dy dx equals this. Now, technically speaking, this is a correct answer, but if it's a multiple choice or if you look it up in the back of the book, it doesn't look like that. Why? Because you can factor. If you look at the numerator, they have a 3 in common. You can factor out a 3. And if you divide each of these terms by 3, you're going to be left with that. And in the denominator, they have a 3 in common. It can be factored out. And if you divide both of those terms by 3, that's what you're left with. Now, because I have a product in numerator and denominator, those 3's cancel. And so now I have my answer. And it matches the one up in the corner here. Okay, so that's going to be my answer. Of course, you're going to make it nice and pretty. You wouldn't have that great big thing through there. Now that's nice and pretty, isn't it? There's my answer. Okay, so moving on to the next one. All right, let's look at this guy. All right, we want to find dy dx, and we're going to use implicit differentiation. Okay, so I'm going to I'm going to take derivatives of both sides with respect to x. So I can do that individually to each term. Now, the derivative of sine is cosine, but we're not done. By the chain rule, we're going to have to multiply this by the derivative of x with respect to x of what's inside here. The derivative of x squared is 2x, and the derivative of y with respect to x is just dy dx. Or the derivative of y is 1, and then it's 1 times dy dx, if you want to look at it that way. Okay, I need to use the product rule there. And the product rule says it's going to be the derivative of the first one. So the derivative of x, which is just 1, times the second one, plus the first one, times the derivative of the second one. And the derivative of y with respect to x is dy dx. Or the derivative of y is 1, and then you multiply it by dy dx. All right. Next, I'm going to take this cosine of xy and I'm going to multiply it by each term in there. So I'm going to have cosine of x times y times 1y. And 1y is just the same as y. But I'm going to write it where the y term's out the front. Okay. Then I'm going to have cosine of x times y times this term. And I'm going to change the order. I'm going to have the x out the front. So x times cosine of x times y times dy dx. Now, the goal is to get dy dx by itself on the left-hand side. So anything that has a dy dx in it, I need to make it appear on the left-hand side. So minus dy dx to both sides here. Okay, so that's gone. And then this does not have a dy dx in it, so I need to get that to the other side. Minus y cosine xy. And so those will cancel. Now, after all of that, this side will be x times cosine of xy dy dx minus dy dx, which is the same thing as saying minus 1 times dy dx, is equal to 2x minus y cosine xy. Okay. Now over here on this side, I'm going to factor out the dy dx's. That's the whole reason why I had dy dx's on the left-hand side. So I'll be left with x times cosine of xy minus 1. Now the goal is to get dy dx by itself I have dy dx times something, so I'm just going to divide both sides by whatever it's multiplied by. So now these will cancel, and I will be left with dy dx is equal to, the numerator will be 2x minus y times cosine of xy, and the denominator will be x times cosine of xy minus 1. And that checks. That is the same thing. So we're halfway through. All right, onward and upward. Okay, let's look at this one. All right. So I want to find dy dx. So what I'm going to do is I'm going to take derivatives of both sides with respect to x. I can do that separately to each term. Okay, so the derivative of e to the xy is going to be e to the xy, then times, according to the chain rule, the derivative of, with respect to x, of whatever the exponent is. The derivative of x is 1. The derivative of y is 2y, but we are taking the derivative with respect to x, so then I have to multiply that by dy dx. I'm going to have to use the product rule for that. So it's going to be the derivative of the first one times the second one plus the second one, plus the first one times the derivative of the second one with respect to x. Okay, now I'm going to multiply the e to the xy through. Everything else is algebra from here on out. So I'll have e to the xy times 1 times y. So that's just going to be e to the xy times y, and I'm going to put the y out the front. Okay, so when I multiply this times that, I'm just going to change the order, and I don't need the 1 anymore. Then I'm going to multiply e to the xy times x times the derivative of y with respect to x. Now that's just dy dx. So actually I'm going to just rewrite that one as dy dx. So I'm going to have e to the xy times x, but again I'm going to put the x out the front. And then times dy dx. Okay, now I want to solve for dy dx. I want to get dy dx by itself on the left-hand side. So anything that has a dy dx in it should be on the left-hand side, and anything that doesn't should go over to the other side. So over here, I'm going to subtract that from both sides because I want to get it over to the left-hand side. So they cancel over here. And this term does not have a dy dx in it, so I'm going to send it over to the other side by doing that. Okay, so now over on this side, so they will cancel. Over on the left-hand side, I'm now going to have x times e to the xy dy dx, then minus 2y, so what's in red, equals, and then over here I'm going to have 1, and then minus the blue term there. Okay, now I put everything with the dy dx in it on the left-hand side by design. I can factor it out. They have a common term. And what I'm going to get when I factor out dy dx is I'll have x times e to the xy minus 2y. To get dy dx by itself, I have dy dx times something, so I divide both sides by whatever it's multiplied by. So now by design, that will cancel. I meant to do that in black. And I'll be left with dy dx. And so here I'll have 1 minus y times e to the xy in the numerator, and the denominator will have x times e to the xy minus 2y. And that is exactly the same as our answer, so I know that it's correct. Okay. Let's come finally to the last one here. Oops, how are we going to solve that one? Get it back on the screen. Okay, so before we do anything else, that's a logarithm there, and I might use the logarithm rules on the left-hand side to split that up. So I have a logarithm of a product on the left-hand side. I can also write that using the product rule as that. So again, to be in calculus, you should have had algebra, and you should know these logarithm rules. And then I'm going to use the power rule here for that first one, because ln of x squared, that 2 can come out the front. Because now what I'm going to do is I'm going to take the derivative of x of every term. So with the first term, that 2 can come out the front. Okay. So the derivative of the ln of x is 1 over x. So I'm going to have 2 times 1 over x. The derivative of ln of y, so I have plus, is 1 over y, but we're taking the derivative with respect to x, so I have to multiply that by dy dx. The derivative of x is just 1, then minus. The derivative of y is just 1, but I'm taking the derivative with respect to x, so it's 1 times dy dx. And I'll just write it like that. Okay, so okay, now it's algebra. Get everything with the dy dx in it on the left-hand side. Anything that doesn't have it, get it to the right-hand side. So I'm going to add dy dx to both sides. So that is now canceled over here. And then I'm going to subtract 2 over x on both sides, and so that's now canceled over there. So I'm going to have 1 over y dy dx, then plus dy dx, which is the same as plus 1 dy times dy dx. You'll see why I'm going to write it like that in a minute. Equals 1 minus 2 over x. Okay. Now, I'm going to factor out the dy dx terms. And I'm going to be left with 1 over y plus 1. Okay. Equals, and here I'm going to have 1 minus 2 over x. Now to find dy dx, it's dy dx times something, so I just divide both sides by whatever it's multiplied by. So my answer is dy dx equals this. Now this is certainly a correct answer. But what if this is a multiple choice final exam and you don't see it written like that anywhere? Because what we have here is a complex fraction. We have a fraction in the numerator and a fraction in the denominator. And typically answers in the back of the book are not written that way. What are we going to do? Well, the first thing I would do, so how are we going to be able to recognize it? So a lot of calculus students get here and then they look at the multiple choice selections and they have no clue. So this is, again, algebra. So algebra, factoring, all this stuff figures heavily into calculus. This is why you have to have the algebraic background to get into calculus. What I'm going to do is I'm going to write the numerator as one fraction, and I'm going to write the denominator as one fractional expression. So I'm going to rewrite 1 here in the numerator as x over x. And I'm going to rewrite 1 in the denominator as y over y. So in the numerator, now that those have the same denominator, I can put them into one fraction. That's my numerator. And then my denominator, since those have the same denominator, I can put them into one fraction. Now, what good is this? Well, again, algebra says if you've got this, a fraction that looks like that, then you take the fraction in the numerator and multiply it by the flip of the fraction in the denominator. So using this, it's going to be the fraction in the numerator times the flip of the fraction in the denominator. And now that's going to give me, well, the numerator is going to be x minus 2 times y, but I will put the single term out the front. So y times all of x minus 2. If you just write yx minus 2 without the parentheses, it's not correct. And then the denominator is going to be x times all of 1 plus y. You must put that in parentheses. If you just write x plus y, if you just multiply x times the first term, that's wrong. Okay, and so that's my answer. And you can see here that that matches. Okay, all right, so we made it to the end. I hope this helped you. There's lots more videos on my YouTube page of all kinds of topics, so be sure to subscribe and check some of them out. Thanks for watching.